Welcome to Rges Algebra 1. This is lesson 31A, and we're going to begin, welcome today, we're going to begin with the Psalm 93, and I'm going to read the whole Psalm, and we'll focus on verse 4. So it says, "The Lord reigns, he is clothed with majesty. The Lord is clothed, he has girded himself with strength. Surely the world is established so that it cannot be moved. Your throne is established from of old. You are from everlasting." So we're focused on God's steadiness, God's unmovableness. Now, when he says the earth cannot be moved, it means in an ultimate sense because God has created it. But it doesn't mean that there's not shifts and changes and circumstances that shake us. And we know that because he goes on in verse 3 and 4 to say, "The floods have lifted up, O Lord. The floods have lifted up their voice. The floods lift up their waves." That's verse 3. And so in other words, things are, our circumstances look bad. Could be literal waves, like a huge flood that hits a portion of the coast, or a tsunami that destroys much, or it could be most likely figurative waves, where anything can be expanded to anything that shakes significantly in our lives. And the fact that he repeats it 3 times means this is overwhelming. This is huge. This isn't a little deal. And then he comes to verse 4, and verse 4 is so centering. He says, "The Lord on high is mightier than the noise of many waters, than the mighty waves of the sea." He finishes it up. "Your testimonies are very sure. Holiness adorns your house, O Lord, forever." Now I want to focus on that one phrase. The Lord on high is mightier. Make that personal to you today. He is mightier than anything that is shaking, anything that is threatening, anything that is overwhelming in your life today. Let's fill in the blanks. The Lord on high is mightier than COVID-19. The Lord on high is mightier than this lockdown. The Lord on on high is mightier than this relational difficulty or family problem. The Lord on high is mightier than financial challenges. The Lord on high is mightier than this sin I'm trying to overcome. The Lord on high is mightier. And so David is so good at this in the Psalms. He recognizes the issues and the problems and the things that overwhelm his life and his emotional shaking. And then he always ends with a new perspective, but God. But God is greater. So cast whatever concerns you today upon your mighty King, and I will do the same. God bless you. Now we want to go to sections 12.1 and 12.2 as a source of review. I'm going to be just doing plenty of review. You have the answers, but I want you to, a lot of kids are intimidated by these square root kinds of problems, and I want you to see that they are not that big a deal. So make sure you have your homework answers, and let's go to 12.1. I'm going to do actually every problem here because they can almost be done in our head. Okay. If x is 7, the answer will be the square root of 21. Now, I'm not going to do the calculation. You can, and they give you the answer as a decimal because they use the calculator, but you can leave it right like this. If x is 27, well, 27 is 3 to the third times another 3, so I've got 3 to the fourth, so that's going to be 3 squared when I pull it out, and that's going to be 9. Could you do it in your head? See how that works? Let me try to figure out how to write a 9 there with my very poor stylus. There we go. So those are my 2 answers. Number 3. The square root of 15 minus x. If x is 6, I've got the square root of 9, which is 3. If x is 15, I've got the square root of 0, which is 0. If x is 20, I've got the square root of a negative number, and so it's no value. That's all there is to it. It's imaginary is what it really is, but that's right. They're using no value right now. It means no real value, real number value. Okay, number 5, 10 over the square root of x plus 4. So I'm convincing you, you can do these in your head. If x is 96, my bottom is the square root of 100. That would be 10. That equals 10 over 10, or 1. If x is 0, I've got the square root of 4 in the denominator, so it would be 10 over the square root of 4 is 2, and so that would be 5. For C, I've got, if x is negative 3, I've got 10 over the square root of 1. The square root of 1 is 1, so the answer is 10. And finally, if x is negative 4, I've got the square root of 0. That's fine, but 10 over 0 is dividing by 0, and so that also is no value, or undefined. Either way. All right, let's go on to number 7. We've got the square root of 2x, the square root of 2x, and now we have find x if the expression is 10. So we'd square both sides, we get 2x equals 100, and x equals 50. So a little bit different approach here. For B, if 2x, square root of 2x equals 3, we square both sides, we get 2x equals 9, and x is 4.5. See what I mean about being able to do these in your head? And finally, for 9, we've got the square root of x plus 5. Whoa. I'm hoping that you've listened to all of this. I guess I have forgotten to, I'm not sure if I forgot to put the tape back on or not. Something funny just happened, so I'm hoping you're seeing them all. It says if the whole expression is 12, we square both sides, we get x plus 5 equals 144, subtracting, and x equals 139. I'm trying to show you that you can do these very quickly, almost in your head. For the next one, you get the square root of x plus 5 equals 2, square both sides, x plus 5 equals 4, subtract, and you get x equals negative 1. And finally, the square root of x plus 5 equals 0, square both sides, x plus 5 equals 0, and x equals negative 5. And that's all there is to it for the whole 12.1. I want you to get very comfortable with this. It's not that hard. Now in 12.2, I want to do also many of the problems, but I'm going to read them, the answers to you orally first. And that way, if you got them all right, you don't need to watch through them. All right? So I don't need to read them actually for you because you have your answers in the back. So if you got them all correct, go ahead and skip over. If you only missed one or two and you were able to fix them, go ahead and skip over this review to the new concept. However, if you struggled with this, let me do an extensive review for you before we go on. Okay, so I'm going to do many of these problems. To simplify, the best way I like to do it for easy ones like this is I think, okay, well, 4 is something squared. So I'm thinking in my mind, 4 times 3, because 3 is not something squared, and so that'll be 2, the square root of 3. Hopefully you can start, with practice, you can start seeing these. The square root of 27, 27 is 9 times 3, or 3 to the third, and that'll be 3, the square root of 3. For number 11, it'd be the square root of 32. That'd be 16 times 2. This is the square root of 4, or, the square root of 16 is 4, and so I'd have to leave then under the radical the square root of 2. Number 15, we've got the square root of 200. That's going to be 100 times 2. This is the square root of 100 is 10. The square root of 2. Let's go to the next page. This might be the first one that gives you a little bit of trouble, but I can see it's divisible by 5, and this is also divisible by 5. So I could reduce this to 5 times 81. I can take the square root of 81. So this becomes 9, the square root of 5. So that's how we simplify them. Now next we've got multiplication. Number 21, we've got the square root of 3 times the square root of 15. I like to break it down as I go. This becomes the square root of 3 times the square root of 3 times 5. This is my pair, so this becomes 3, the square root of 5. And again, what am I doing? By showing you such a multitude of problems, I'm hoping you see how quickly you can do these, and very shortly you'll be able to do these in your head. So square root of 8 times the square root of 2. Again, I like to break it down as I go. 8 is 2 times, I could say 2 to the third, or I could say 2 times 2 times 2 times 2. Take every pair out, and this is 4. 29 is the square root of 5 times the square root of 30 times the square root of 3. I'm going to write them. 30 is 5 times, or 3 times 10, or 5 times 2 is 10 times 3 times 3. This is a pair, and this is a pair. Out front, we get 3 times 5, or 15, and what's left over? The square root of 2. 33, we get 8 times the square root of 2 times 5 times the square root of 12. First, multiply out what's out. This is 40, and write everything under 1, 2, 12 is 2 times 6, which is 2 times 3. Pull that forward, that'd be 2 times 40 is 80, the square root of 6. Hey, one sec. Okay, number 37, let's continue on here. Again, what I like to do is I like to just go ahead and multiply what's exterior, simplify, or write out the combination of what's under. Okay, so this will be 30. The square root, 18. If you already know it's it's something that can square, go ahead and just write it like that. Okay, sometimes that would be a problem, but it's not here. And 2 times 7. So this is a pair. This comes out, so that'd be the 3 comes out, and the 2 comes out. That'd be 3 times 2, 6 comes out. 6 multiplied by your 30 is 180. And what have I got underneath still? Square root of 7. Now, all of that, I think you can often do just in your head. Okay. Now, when we get to these next ones, not so much, but they're still not that complicated. Some of them can be done in our head, obviously, like 41, because all I need to do to be able to add is have the same root and the same index, or the same radicand and the same index. So square root of 5, square root of 5, so 2 plus 7 is 9. So that certainly could have just been, an answer could have just been written down. Number 45, same idea. 13 square root of 6 minus square root of 6. These are the same, they can combine. And so I got 13 minus 1, or 12 square root of 6. Um, 49. I've got 7 square root of 5 plus square root of 45. Square root of 45 you want to treat just like our first section. That is 9 times the square root of 5. We know what 9 is. That would be 3 the square root of 5. Okay, bring that back here. That's the simplification. I have the same radical, and so 7 plus 3 is 10 square root of 5. See how these work out? 53. 6 square root of 12 minus square root of 75. Hopefully these are so easy, you're doing them in your head. I'm thinking 4 times 3, so 2 times 6 is 12, square root of 3, minus 25 times 3, that'd be 5 square root of 3, and so my subtracting 12 minus 5, and you're going to get 7 the square root of 3. Okay, 57 then. It's just because I have 3 terms, there's no difference whatsoever. I'm just going to simplify and gather what I can. Okay. So this would be 20. Okay. So this one doesn't simplify. The next one, I'll go ahead and write out all primes. This would be 2 times 40, which is 2 times 20, which is 2 times 10, which is 2 times 5. I think I wrote that down right. 8 times 2 is 16 times 5 would be 50, 80. Yes. Okay. And now the next one is a little easier because I see that as 4 times 5, so that'd be 2 the square root of 5. This one, I gathered these, so this would be 4 the square root of 5. Now, I notice that all 3 doesn't have to be all 3, okay? They could have given me a problem where only 2 of them matched. But in this case, all 3 match, so I'm going to say 3 minus 4, that's negative 1, plus 2 is positive 1, or I could say 5 minus 4. Either way, I'm gathering up all these things, right? Oh, whoops. This and this. So 5 minus 4 is 1, so your answer is the square root of 5. And that's really all there is to it. Now those number 61, I did not assign you, but it's actually even easier. We went over it in class a little bit last time, but x to the 7th, think an even number, x to the 6th times 1 more. So I'm thinking in my head. I'm not even thinking on paper. I'm thinking that what's half of that equals x to the 3rd times x. These are very easy to do in your head. Ready? Here we go. The next one, I've got the square root of, the square root of x to the 5th. Drop it down to an even, x to the 4th, that would be x squared on the outside, and the square root of x still underneath. Y to the 9th, drop it down to the even one, that'd be y to the 8th, take half of that, y to the 4th, and we've got one more still underneath. See how it works? X to the 6th, that's already even, to cut it in half, and be x to the 3rd. X x to the 8th, y to the 3rd. The x's are already even, cut it in half, x to the 4th. The y's are odd, drop it down 1, y squared, half of that is y, and we need that 1y remaining under the radical. Hopefully this is so easy that you can do it as simply as I can. These are both even, drop them in half, you're going to get x, y to the 5th. Okay? So if they're odd, you're going to expect one to stay under the radical. If they're even, you're just going to be able to pull everything out. And that's all there is to that. Now we want to start our new idea. 12.3 is quotients of radicals. Now there's two concepts here in 12.3. These are quotients with radicals. Quotients are what? Division, right? Fractions. So the first idea is that if you have something in the numerator and something in the denominator, like this, that is the same as putting them under one radical sign. And so if they divide evenly, that's wonderful. This does divide evenly, and it goes in 17 times. And so that's one way to simplify. If they're under two radicals, the numerator's under radical and the denominator's a radical, see if they divide evenly. And if they do, you just do that. Now, if they don't divide evenly, the second way I look at simplifying a radical, for instance, if I have 5 over 7, let me fix that 5 so it looks... Okay. So now what happens is putting them, I could say square root of 5 over 7, but that doesn't help me at all. So I'm not going to really do that, because 5 over 7 can't be simplified. So what else can I do? It's considered simplified when you get... when you have no radical in the denominator. So I'm going to change this now because I can't simplify it like in example 1. So I want no radical in the denominator. Well, how would I do that? Well, I'm going to multiply the denominator which by the square root of 7. And so that I don't change the entire value, I have to multiply the numerator also by the square root of 7. Now what does that do for me in the numerator? That makes it the square root of 35. But what does it do for me in the denominator? The square root of 7 times the square root of 7 equals 7. And so then you have no radical in the denominator, and that's the second way we consider something simplified. We consider it more simplified. We consider this, even though the numbers are bigger, a simpler expression than that. Okay? And that's really the whole idea. Now let's go ahead and give you several examples. Number 2 says 8 over the square root of 24. Step 1 will be, I'll simplify that, because we know that that's 4 times 6, or 2 outside the radical times the square root of 6 underneath. Now, to simplify this, there's several ways you can do the order. It's going to bug me. But to simplify this, I want to get rid of the radical. And the radical is the square root of 6. So I'm going to multiply it by the square root of 6 times the square root of 6. Okay, just like that. Okay. Now, this becomes then, in the denominator, in the numerator, it becomes 8 the square root of 6. In the denominator, it becomes 2 times 6. See that? Because this combines with this to just give me not square root of 6, but just 6. Now we're going to simplify by taking 2 divided into 6, or 2 divided into 8, and also, so we'll cancel here. 2 goes into 8 4 times, and a 2 divides out of here and here to give me 2 and 3. So altogether, after simplification, I get 2 the square root of 6 over 3. And that's the way I like to do it. Okay, I like to simplify the radical. I like to multiply both the numerator and the denominator, and then I like to cancel. All right? So let's give you some more practice. 8 or 4 or 2 do not divide both into the numerator and the denominator, so there's no sense in putting both the numerator and denominator under the same radical sign. So now I'm going to simplify. The numerator would be 3 times 25, or 5 the square root of 3. The denominator would be 2 times 4, or 2 the square root of 2. And hopefully you're getting so good at that I'm not going to bother showing you, right? Now, I need to get rid of the square root of 2 in the bottom. So this becomes 5 the square root of 6 over 2 times 2, or 5 the square root of 6 over 4. Let's look at another one. If I have the square root of 24 over the square root of 50, and I want to divide that by the square root of 27 over the square root of 8. Well, this is a little more complicated, but it's not really all that complicated, because I'm going to rewrite this as, this is 4 times 6, or 2 the square root of 6. I'm going to rewrite this as 25 times 2, or 5 the square root of 2. I'm going to pay attention to this by doing the reciprocal. And I'm going to rewrite this in the numerator. That's 4 the square times 2, or 2 the square root of 2. And I'm going to rewrite this as 9 times 3, or 3, right, the square root of 3. Now what do I do? All right. Well, notice that what I'm going to do is multiply the whole numbers and multiply the I'm actually not going to do that. Okay, this is what I'm going to do. Okay, let's pay attention to just the whole numbers. This is an easy way to do this. This becomes 4 over 15. Now, paying attention to the radicals, this can cancel, and 3 goes into 6. I'm thinking, okay, I'm going to write that part like this. 3 goes into 6 2 times. And that's in the numerator going to be the square root of 2. Well, that was easy. And now let's do one more. Okay. We're going to have the square root of 12 over the square root of 50 minus the square root of 27 over the square root of 8. Go ahead like I did. Write everything simplified. This would be 4 times 3, or 2 the square root of 3, 25 times 2, or 5 the square root of 2. See how this is becoming so easy for you, I hope? 9 times 3 is 3 the square root of 3, and this would be 4 times 2, or 2 the square root of 2. Now, can you rationalize these denominators in your head? I need to multiply by the square root of 2, and so the denominator becomes 5 times 2. The square root goes away, right? So 5 times 2 in the denominator, 2 the square root of 6 in the numerator. So this becomes 2 the square root of 6 over 5 times 2, or 10. This becomes 3 the square root of 6. I'm only worried about getting rid of this. 2 times 2 in the denominator is 4. See how I can do that in my head? Okay. If you can't, go ahead and practice it a little bit. Okay, but what I do, again, you're taking the 5 times this without the denominator, without the square root, and you're taking a square root of 2 to combine with this. Okay, that's the kind of thinking. Now, I need a common denominator, right? So that'll be 20. So my multiplier here will be 4, the square root of 6. This would be a multiplier of 5. 5 times 3 is 15. The square root of 6. All over 20. I don't know why my stylus is causing trouble. Okay, 4 minus 15 is negative 11, square root of 6, all over 20. 11 and 20 don't do anything to one another as far as being able to simplify, and that's my answer. Now let's just go as far as oral problems. That's the last thing I want to do, is if you're looking at oral practice on page 531, I would just want to do A through F, seeing if we can do these fairly much in our head. What am I thinking? This becomes times the square root of 3. This becomes 2, the square root of 3 over 3. B, think about it before you let me tell you the answer. What would it be? 5, the square root of 2 over 2. C, 1 over the square root of 5. I'm trying to move that radical to the numerator, right? So it's square root of 5 over, no longer under the radical, 5. D, this will be 3 over square root of 7. I'm trying to move that up to the numerator. How do I do it? 3 times the square root of 7, and this becomes in the denominator outside the radical sign. See? E, this becomes, E is 6, the square root of 3. This becomes 6 times the square root of 3 over 3. The only difference here is go ahead and simplify that, and that becomes 2, the square root of 3. And the last one I'm going to show you is F. 10 over the square root of 5 becomes, take it to the numerator, 10 the square root of 5 over 5, but go ahead and simplify to the square root of 5. See how we can do these orally? The more you practice doing oral math, the simpler the whole process becomes for you. Now let's talk about your homework. Okay, you're going to just do 12.3, 1 through 45, odd. This quiz has already been sent. This test has already been sent. Some of you have sent them back. And if you haven't, I will be sending for everybody a new quiz that's going to be on Wednesday. I will attach it. So a new quiz given on Wednesday. I'll talk about that on my Wednesday or lesson 31B. Okay. And then all mailed in by Friday. If you have not already mailed it in, I want all mailed by Friday. And that's it. You guys have a wonderful day. Make sure you're keeping up. You know, it's only about 5 weeks till school's out. Okay, so just keep plugging away and hang in there, guys. God bless you.